So in this example, we have Batman invest $2,500 into an account that earns an interest at an annual rate of 4.25%. Find the future value of Batman's account after 7 years if the interest is compounded annually, monthly, and daily. So we have 3 different scenarios that we're going to take a look at: annually, monthly, and daily. So the formula that we want to use here is going to be the future value is equal to the principal amount times 1 plus r over n, and I'll define r over n, or r and n in a second, times n, or not, raised to the n times t. So 1 plus r over n to the n times t, where r is our rate, n is the number of compounds per year. So for example, if we had annually compounding, it's going to be 1. If we had semi-annually, it's going to be 2. If we had monthly, it's going to be 12. So that's the number of compounds. And then t is going to be time period here. So for letter A, we have $2,500 into an account that's 4.25, so the rate here, and this is a huge mistake that I always see, believe it or not. Rate is 4.25%. That is a decimal, is 0.0425. I cannot emphasize the number of times that I've just seen 0.425, just not moving that decimal out accurately. Like, really easy mistake to make. So just, it's a really silly mistake to make also. So you don't want to get all this wrong, all this like business calc or calculus type of work wrong, just because we're not moving the decimal accurately. So rate is going to be 0.0425. And letter A is annually, and I already kind of alluded to that. So annually means that we're going to compound it once. And time is going to be 7. So here we go. So the principal, 2,500, times 1 plus the rate, 0.0425, over the number of compounds, which is 1, raised to the n times t, and we are doing 1 compound per year times 7 years. So just 1 times 7, which is 7. And then from here, it's just go into your calculator. So 0.0425 divided by 1 is going to be 0.0425, so we're just going to do 1 plus 0.0425 raised to the 7th times 2,500. So yeah, that's a really easy mistake to make right there that I see a lot. We want to make sure this part is being raised to the 7th. And once you get good with your calculator, like, you just type this all on your calculator screen at one time. But just starting off, I would do the inside, raise it to the 7th, and then multiply by 2,500. So then I would get 3,345.59. Next, we want to do monthly. So how many compounds monthly? That's going to be 12. So that means we're going to have principal, 2,500, putting into the bank. 1 plus the rate is not changing, 0.0425. And we're going to compound this 12 times a year. And we're going to raise that to 12 times 7. 12 compounds in a year times 7 years. So we're going to do 0.0425 divided by 12 plus 1, raise that to the 12 times 7 times 2,500. And here, compounding it monthly, we get 3,364.45. Take a notice here. Look what happened. We compounded it annually. Look at our amount compared to monthly. What's happening? It's increasing. We're getting more. And then the last one, we want to compound it daily. So daily, how many times are we going to do that if we are doing it daily? There are 365 days in a year. So 2,500 times 1 plus the rate, 0.0425, divided by 365, because we're doing it daily, raised to 365 times 7. So just do the same thing, 0.0425 divided by 365, add 1, raise that to the 365 times 7 times 2,500, And we get an answer of 3366.16. So that was daily. Now notice, annually 3345, monthly 3364, daily 3366. From monthly to daily, didn't go up a whole lot, but still increasing. So you can see the pattern developing that the more we compound, the more money we're going to end up with. And that was a fairly low amount to be investing into an account. I guess a pretty good chunk of change, but not anything that's going to really start to see a big difference as we increase that compounding. Like if we were putting 500,000 or $1 million or something crazy, then we're going to really see some big gaps in these compounds. But starting off, that's a pretty low amount, so we're not going to see a huge change from even annually to daily.